Hello, everyone. So, yeah, hello. So let's start. Something happens. It's not. So it's really hard to prepare the presentation because first you need to spend a lot of time learning about the context and everything. Then you need to put some time on putting the slides and everything together. And then it's not easy to present it. You finally think you finished everything, you come to the stage, and first you forget this thing at home, so you need to go to the shopping mall and buy another one, and then some things like this. And it's not just with presentation, it happens with other things. For example, web development, it's quite hard. When you start, you need to learn a lot of things. First, what the heck is HTML? And how do you put those two divs or buttons next to each other with CSS. And finally, you come to JavaScript, and that's magic. Then you find out that 0.1 plus 0.2 is not what you expect. And finally, you kind of manage to learn many things and to build your awesome application. And finally, you have something, and you run to your friends to show them your great application with your laptop or something like that. And everyone is happy for you because you're learning, and then you just want to send that presentation to someone else. You want to send your application to your friend that lives in Canada or somewhere, or maybe just to share it via Twitter or something like that. And then you ask yourself, how do you do that? You learned a lot, you worked a lot to build something, and it's not just trivial to show that to someone. And of course, you need a thing called server. Yeah, it's not cool, but I guess you can buy a server, so you go and buy it, but that's not the end of your pain. You realize that it's not easy to just put your application inside the server and send that to someone, because there are a lot of different things that you need to do. First, you need to install some things. Hopefully, it comes with the operating system, but your pet somewhere in the clouds, in Germany or US or something like that, it's not working yet. You need to install a thing called Nginx or whatever. Then you need to upload your application somehow to set up everything, and then you don't have a domain, or you need to install SSL, and it's too hard. And you realize that putting your application inside that cloud is more like this, so confusing and hard. And you just want to show your application, so you're confused, and then you just try to Google what's the easier way to show your application to the world and everything. And then you think how everything should work. It should be simple, right? So whenever you want to show your application to someone, you just need to focus on, you should just focus on building your application, and then you should have a big button or something like that that will just deploy that and make it available to everyone. So, for example, I think deploying a front-end application should be like one command, or maybe even automated with Git or something like that, but really simple. Then it should be cheap, because you don't want to pay like $10 per month if you just want to show your first website to your friend in Canada or something like that. Actually, it should be free if you just want to show it for a few to a few people. And it should have caching and auto-scaling and things like that if you want to grow that to some more product or something like that. Sometimes you start small, but then the thing that you made, people start using, and then you need to pay more, and even before you start earning from that. So it should be cheap, easy, and of course scalable, and you should be able to pay more if you have more visits and more users. And that feature list sounds familiar. And if you do a quick Google search, you'll see that there are services that allows you to host your front-end applications easily, like Netlify or GitHub Pages or AWS S3 and things like that. So finally, you can build your application and then easily deploy it somewhere and show it to your friend. But that feature list sounds like something else. It sounds like serverless. And why I'm here, and because serverless sounds like a backend thing, right? This is a front-end conference focused on JavaScript and design and things like that. Well, serverless is a backend thing, but it's a backend thing that gives superpowers, actually that can give superpowers to front-end developers. And actually, this is, who was on the previous presentation? Anyone? So in the previous presentation, Conrad said that we shouldn't be afraid as a front-end developers that we will lose our jobs soon, but don't worry, front-end developers, even if they don't need to focus just on design anymore, because there are tools that help you to do many other things. There are tools that helps you to kind of take some job from a backend developer. So don't worry, we'll have a lot of things to do in the future. So before we continue, and before we continue speaking out about serverless, let me introduce myself. I'm Slobodan Stojanovic. I work as a CTO at a small company called Cloud Horizon. We're doing mostly web-based projects. Some are serverless, some are front-end applications, some are some crazy things like bug tracking system for real bugs in the rooftop greenhouse and things like that. So there are really cool things. Some are less cool. I also wrote a book with my friend Alexander Simovic called Serverless Applications with Node.js for Manning Publications. It should be out of print. Actually, it should start. I should receive the first printed version in September, but now it's available as an ebook. And I'm also AWS Serverless Hero, whatever that means. I'm still waiting for my cape, but I didn't receive anything yet. I hope I'll receive something. And you can follow me on Twitter. And also, with my friend Alexander, I often write about serverless on effortlessserverless.com. So before we continue, I would like to know something about you too. So who's here a front-end developer? Okay. So who's full-stack developer? Okay. And how many back-end developers do we have here? Okay, cool. Okay, perfect. So let's get back to serverless. So what does that mean, serverless? Do we have less servers, or are there any servers at all? Some people said that we even have more servers today with serverless, which is kind of weird, but whatever. I would say no one cares about that. No one should care with serverless, except probably Amazon or Google or other service providers like Microsoft and IBM. I really hope that they care about servers, because I really don't care about them anymore. So to be able to explain serverless, I need to go a few steps back. So what do we need to make our application, any kind of application, functional? We started with a server. So basically, we need to buy or rent some kind of a server. Then we need operating system. Either we need to install it or it's already there. Then after that, we need to set up the server with some other things, as I mentioned, Nginx or who knows what your application needs, maybe Node.js and a bunch of other things. Then you need to write your code and to have your business logic and actually have your application. So it's not the first step, it's actually the fourth step. Then after that, you need somehow to deploy that application and be able to send it to everyone. And after that, you need to make sure that your application works all the time, because it's not like magically when you finish your work coding, then problem starts at that point most of the time. And people find different bugs and servers are not like working all the time and things like that. And after that, you need somehow to manage your server and software and update everything, update operating system, and patch the crazy things like Spectral, Meltdown, and who knows what. There's a lot of things that you need to do. And your code, and of course, your job is not over at that moment. You still need to maintain your application. When people start using your application, then you realize that there are a lot of bugs and there are some new features and things like that. So it's a long list in building and showing some kind of web application. So if we compare this list with things that are important for our business, or for us, if you're building something just for fun and things like that, the list is much shorter. Business cares about business logic, actually not about how you code application, but they cares about if business logic that they want to present to users actually work. They care about that your application works all the time and that people can use that. And finally, they care about application updates because they want bugs fixed and they want new features and things like that. So there's a huge list of things that we need to do, and there's just 3 things that business cares about. They really don't care about the other things. You need to do them, but they're invisible to end users and to your, unless you have any problems, and to your clients or your boss or anyone else in the business. So, isn't the cloud helping with this? Well, cloud helps with some things. With cloud, it's easier for us to buy or rent the server. We can just turn on and turn off the server quickly, and we don't need to install the operating system. And there are a few other things that are quite easier with the cloud, but it's not solving all the problems. So first 2 things are basically solved by the cloud, so we don't really need to think about them that much unless we want to scale our application and things like that. But there's the next step. Serverless is kind of a next step that should help us to don't care about some other things from this list. For example, with serverless, we don't care about setting up the server anymore, installing Nginx and things like that. We don't know what's in the box, but it works. That's the important thing. And also, we don't need to care about updating our server, maintaining, patching everything, because that's done by service providers such as Amazon or Microsoft Azure or some others. And also, it helps with some other things. It doesn't fully solve them, but it helps a lot with deployment because it simplifies some things. And also, with monitoring, it will not monitor your application, but at least they will make sure that your server is working. So if something crashes, they will make sure that other instance is working, so one user don't affect all the users on your server and things like that. So if we compare the list that is important to a business, those 3 things, with the things that we have to care about with serverless, we see that the lists are almost the same. So we still need to write our code to care about the business logic in our code. We still need to manage our application, such as updates, fixing the bugs, and things like that. We kind of need to figure out how to deploy that, but that's just one. Actually, we need to pick one of the options for the deployment. That's one-time thing. And also, monitoring is, we still need to monitor our issues inside the application, but we don't really need to monitor if our servers are up and things like that anymore. So, kind of serverless, at least in theory, helps with some of those things, which is kind of cool and give us some ideas how we can use that to improve our things. So there's a really, really important question that everyone asks with serverless, and it's like, why is it called serverless? There are servers in the background, and it's hard to explain that, but my friend Gojko Adžić has the best explanation ever. He said that it's serverless the same way Wi-Fi is wireless. So whenever you visit Twitter or Google or anything from your home, from your phone, you don't need to carry wire with you all the time. But at the end, whenever you do something, your request eventually hit the wire, but that wire is not yours. It's whoever's. Maybe someone's in this building with the routers and things like that, or provider, or you don't care about those wires anymore. They're not yours. If something breaks, it's not you that needs to manage them unless your home router is broken or something like that. So I think that explains that very well. So what are the benefits of that serverless thing that I'm talking about? First and obvious benefit is managed infrastructure. So we don't need to manage server, we don't need to set up server, we don't even need to care if we have server or not because we don't care about that anymore. We should just focus on our application. It's like we write the function and we put function in some black box, and that black box will run that function whenever it needs. I'll explain a bit later how does that work. Also, it's cheap. How cheap is that? So for 1 million requests, for example, AWS Lambda or Azure Functions, 1 million requests per month costs you 20 cents. So it's really, really, really cheap. And it auto-scales and it has auto failover. So if you have like one person using your application, then you'll have one instance. But if in next minute you have another 500 people using your application simultaneously, it will just work for them. It will scale, and then you'll pay just for those requests. Also, every function is isolated completely. If I have some issues with my request, it will not affect anyone else that is using the same application. Everything is fully isolated. And it's easy to start with. It's beginner-friendly. So the most important benefit of serverless is nothing from that list. The most important benefit from serverless is basically pricing model of serverless or economics of serverless. And here's how that works. So you're not paying for reserved capacity, like buying a server or something like that. You're paying only for used capacity. So if you have those 1 million requests each month, you'll pay those 20 cents. But if you have like 1 million requests for one day, then you'll pay 20 cents for that day. But you will not continue paying 20 cents every next day because you are paying just for used capacity, not something that you reserve. And basically, yeah, that's pay-per execution model. So the important thing is if no one is using your application, so for example, if you build a small application just to show that to your friends, it will cost you $0. It doesn't cost you anything if no one is using it, which is really cool. And also, there are really great free tiers. So first million requests each month for both Microsoft and AWS are free. So basically, you're paying just the second million requests, which is really, really great. But yeah, you can send your application to your friend now. But we're on the Frontend conference, and pricing model is definitely not something that gives superpowers to front-end developers. Maybe it can give superpowers to people that works in banks. We're in Zurich, so there are a lot of banks around. But let's talk about the things that we care about. And those things are like superpowers. So to understand how to give someone a superpower, we need to understand what's something that is hurting us and what's our kryptonite. And there are a lot of things that are hard for front-end developers. And one of the things that I asked was like, are you full-stack developers or just front-end developers? It's hard to be full-stack developer. It's like most of the people that consider themselves full-stack developers are focused either on front-end or on a back-end. Back-end developers are like full-stack developers if they know jQuery and maybe some Vue now or something like that. And if you ask front-end developers, they're like, I can write some Express.js application, and I know how to follow that great tutorial to put it on DigitalOcean, and it will work. And of course, that's great. That's something that we can do. But if we want to be real full-stack developers, then we should know a full stack, and we should know how to kind of scale and do all the crazy things to our application that we really don't want to know. So in order to give front-end developers superpowers, we should allow them somehow to work with the back-end things, but without really knowing the operating system and all those crazy things that some people like DevOps, and I really don't like that. So before I tell you how to do that, I want to do another thing and show you how other people are using serverless, because it doesn't worth anything if I just talk about something and no one else is using that. So is anyone using serverless? There are a lot of people that are using serverless. If you Google that, you'll see that Netflix and a lot of other companies, huge companies are using serverless. But do we really care about the huge companies? Most of us don't, at least I don't work in the huge company. I don't have the same set of problems as Netflix or Facebook or some other companies. I care about smaller companies, the companies with few dozen people, something like that, with a small team that need to deliver some important things to production. And I'll tell you a story. Do you know CodePad? Who use CodePad? Most of you, yeah. So here's how does that work. whenever you want to do some small experiment online, you go to CodePen, then you write some TypeScript, less SAS, PostCSS, who knows what, and that's uploaded somewhere to the cloud. And then by some magic in the background, guys from CodePen convert that to JavaScript, CSS, and HTML that our browsers understand. And then we can see all those cool experiments, animated things, and all the other amazing things that people are working on. So it works amazingly, and it's really amazing how smooth they made it. And they have a lot of requests. All those converters, like preprocessors, how they call that, are taking some, for example, TypeScript and converting them to JavaScript. And that's a separate API that has 250 million requests per month. It's a huge amount of requests. And how many DevOps engineers do you think they have taking care about preprocessors? Any idea? One? 5? Yeah, they have 0. And there's actually 0 backend developers working on that. So, yeah. So I'll return this to a number. So front-end developers can do something that can serve 250 million requests per month, which is an amazing number, at least for me. So how do they do that? They have a small team. Mostly, they mostly have front-end developers in their team. They have just one DevOps guy, and they have few guys that knows backend. And they have Ruby on Rails backend. That's the application. When you go to CodePen, you see the application. Then that application is Ruby on Rails, and it's really nice. That DevOps guy is maintaining that because it has a lot of requests and things like that. They have many preprocessors. If you go to CodePen and try to change the things that you can use, you'll see that they have like at least more than 10 preprocessors that are doing crazy things, and then they have different versions of those preprocessors, because it's not the same if you have like latest version of Babel and some previous version and things like that. And they need isolation for all those things, because you can do really amazing and crazy things with less and SAS and things like that. And in peak, they have 200,000 requests per hour, which is a lot. And the biggest problem is that they never know when is the next peak, because someone can share the pen on their Twitter account or something like that, and that pen can become really, really viral and popular, and then they have a huge peak of the requests, and then after that, they don't have a lot of requests. So their initial idea was to keep having that Ruby on Rails application that is connected to a database, and then to add another server with all those preprocessors. They need to maintain it, but they have one DevOps guy. They would figure that out somehow. But the problem with this was that people on the internet are creative, so they figured out how to run the functions from less and SAS and do some crazy things with the server. And this is not really isolated. When you affect the first thing, then everything can just burn. So that was a bit of a problem. Of course, they thought about containers, but they have really limited resources. CodePen is free, so they don't have unlimited budget. They need to think about their budget, and they don't have a lot big DevOps team. So they tried something else, and actually their DevOps engineer suggested them to try serverless on AWS. So what they did is that one of the front-end developers took SAS preprocessor and moved that to AWS Lambda. It took a few days to learn the ecosystem and everything, but after a few days, they had the first preprocessor in AWS Lambda, like first serverless preprocessor. They connected that and put that in production, and it worked really well. Everything worked so well that their front-end team focused on moving all the other preprocessors to AWS Lambda. And now, whole system looks something like this. So they still have a big Ruby on Rails website. It's connected to a database. And they have everything else is kind of serverless. They have that API gateway that receives the requests. And that API gateway will trigger Lambda functions. So for example, if 500 of us visit CodePen at the same time and try to do some Babel experiment, that API gateway will trigger 500 Lambda functions. And then each Lambda function will figure out which things should be pre-processed, like SAS, ES6, or who knows what, and they will trigger other functions that will do just processing of that, and everything will come back to the front end. Everything is async, so whenever you do something on CodePen, there is a small delay while they're building everything in the background, which is okay. You're just building things, and if something shows up in half a second or something like that, it's not a big deal for them. So this is, they didn't optimize this fully, but they have amazing results. First, everything is fully isolated, each function. So even if someone tries crazy things with less or SAS or something like that, AWS Lambda doesn't allow that person to do anything, because AWS Lambda function is read-only, and you have access to it only while it's running. So you have access to it like 200 milliseconds. And you can't really do anything, because even if you do anything with that one Lambda function, it will die immediately, and other Lambda functions are not affected in any way. Then they have autoscaling, so they can, at the moment we talk to them, they could support up to 5,000 parallel requests without doing anything. So if they have like 2 users using CodePen at the moment, next moment they have like almost 5,000 users, everything will still work perfectly fine for them. They don't need to pay for those 500,000 Lambda functions when they're not working at all. They decrease the infrastructure cost. So I mentioned 250 million requests, and they pay for them like a bit around $1,200 per month, which sounds like a big number, but it would be even bigger with the traditional servers, and they can decrease the cost of this for like 3-4 times, but they didn't optimize everything because they didn't have enough resources, and they're investigating to use some other things inside browser to drop the prices for some of those things too. But from that price, they pay $1,000 for API gateway at the moment, and they pay only $200 for AWS Lambda. So real processing costs them $200 per month. So that's amazing. And their DevOps engineer can just focus on the Ruby on Rails application. He don't need to take care about the preprocessors at all, because everything is managed by AWS. And they have a team of front-end developers with superpowers. They can do even more things now. They learn some of the kind of backend things without really knowing the bottom of the stack and how everything works under the hood, because they really don't need to know that with serverless. And that's real superpowers, at least in my opinion. And that's not the only story. I have more of those stories. Here's a quick one. This is our in-company startup. We had issues when we reached like 15 people. We had issues how to track vacations. We could just bought something like Babu HR or something like that, but that was expensive for a small team, relatively small team, and there was a lot of other things that we wanted to focus on, and it's much better for us to send our developers to conferences or do whatever than to pay that kind of software. So what we tried is to build a small Slack application. We also didn't want to remember another login, because there's a login for Slack, there's login for Jira, for Trello, and for many other things. And we don't want to make sure that we have another service that we need to add new developers to, and it's too complex. So we wanted to build something really easy and fast for Slack. So what we did, we started with one man that was full-time on that, and there was some help from other people from the company, and that guy is a full-stack developer. But the full-stack developer, the way that I explained in the beginning, he knows how to build an Express API and connect it with MongoDB, but if he needs to deploy that to a server, he'll follow the tutorial and do that. But if we release that to production, it will work for some time. Then we'll have really big issues, from my experience at least. And what we built is Slack chatbot. It's like you can request your vacation from Slack, and then that will hit some kind of API. And also we have Angular dashboard where you can see the calendar and many other things. And to minimize the cost and to speed up the development, because we didn't have unlimited budget, we didn't want to take a seed round or something like that, we basically tried to use serverless from the very beginning. And it worked. this is the current state of the system. It looks complex, but it's not complex at all. So basically, whenever someone types something into Slack, it hits some kind of API. That API will trigger either API or separate service for Slack or a separate service for Slack events in the background. That will connect to DynamoDB and MongoDB. MongoDB because he worked with MongoDB in the beginning, and with Express, so we moved some things. And also with Stripe for billing. And whenever we want to send some scheduled notifications, for example, to let your team who will be off next week, we have some CloudWatch cron job in the background, which is, again, serverless, that will hit another Lambda function, and that will respond to your Slack automatically. And also, we have a website, that dashboard, this single-page application that is hosted on S3, and it has Cloud Front as a CDN in front. And everything inside that box will scale automatically. And so far, it works really nice. And we have almost 100 teams using the system. We have, I think, 1,000 vacations requested from Vacation Tracker in the past few months. The infrastructure costs us $0 because we still didn't pass 1 million requests per month, because this is not something that you use all the time, so everything is really cheap. We have really fast development cycles. So we think about a new idea, and next week that idea can be deployed in production because it's ready. We don't need to, everything is separated into small services, and if that wasn't a good idea, we can just kill that Lambda function and no one cares. It's not changing the rest of the system. We have easy refactoring for now, at least, because we have all those smaller services. So if we want to change something related to the API, we don't need to touch the chatbot and other things. And we have some really reusable parts for some of our future applications. For example, full billing with Stripe is like a module that we can just plug and play in other applications. And it works something like this. So you type /vacation, and then you have a small calendar inside Slack. You select when do you want to go on vacation and confirm, and that's it. Your administrator, actually your HR manager or whoever, can receive that request in the Slack and just approve it or reject it with some message, and you can see the schedule. You can have some small notifications in the system and things like that. So the huge benefit for us was that one front-end developer was able to build everything without asking any back-end developer or any DevOps to set up the system or do anything like that. And everything will just scale automatically without, we don't need to do anything to make it scale. And that was really cool for us. So, let's talk about the most important part and where to start. This sounds really cool, but it's like theory. So let me give you a few examples and a few things that you cook at home. So first, and the thing that I mentioned first was single-page application or static website, or you have, for example, Jekyll or something like that. So how you can do that in, I'll show AWS examples. There are similar services in Amazon or, in Microsoft or Google and IBM. So if you're using something else, services will have different names, but they should work quite similar. So if you want to do front-end application, you just need to take your single-page React application or something like that. For example, create React app, then you build it. Then you need to upload that to AWS S3. It's a static file storage. Who used AWS S3 in the past? Few of you. So you can put images there or anything you want, but you can also put there HTML and CSS and JavaScript files, and it will work. And also, you should put CDN in front of that, and that's AWS Cloud Front. And that's it. Whenever someone requests, go to vacationtracker.io or something like that. Actually, dashboard.vacationtracker.io. It will hit the cache, and if it's not cached, then it will serve the file from S3. And there are tools that can simplify deployment, and one of the tools that I mentioned is Kotti.js. It's a library that I made with my friend. You can create React app, then you need to do Kotti --spa --source and put the source, and that's it. you have application deployed in a second, and if you open it, it will just be on the internet in like less than 1 minute or something like that. Depends how big is the application. So there are tools that simplifies all those things, all those complex graphics and things like that. Another case that is quite common is Express.js applications. So as I said, many people knows how to do some things with Express.js, but then you need to deploy and maintain that, and that's complex. So if you have an Express.js application or simple API and you want to deploy that, you can do something like this. You can take your code, put that inside Lambda function, and then put the API gateway in front of it that will just pass all the traffic, all the routes and everything directly to your Lambda function. And that will work fine. So what's the benefit of that, except, of course, being easy to serve that application, which is a good benefit for the beginning. Benefit is something like this. So if you have just 1 user per month, or 10 users per month, or 100 users per month, it will cost you $0 per month. If you have more users, at some point, maybe you shared that on Product Hunt, or someone tweeted that, or it appeared on Hacker News or something like that, and many people come to your application, it will just automatically scale, and API Gateway will just wake up more of those Lambda functions that contains your Express.js application, and that's fast. That doesn't take more than like few hundred milliseconds. Most of the time when functions are warmed up, it's like 100 milliseconds or something like that. So it doesn't take a lot of time. And Amazon will always have more of your functions ready. So if more people try to access your application, it will work. And if you want to try to do that, there's a small tutorial how to do that. I'll put those slides online later, so even if you don't take a note. This tutorial will show you how to build a small Express application and deploy it with AWS Lambda. And how does that work under the hood? So whenever API Gateway receives a request, so someone wants to log in into your website or something like that, it will trigger a Lambda function. But as Express application is HTTP server, that Lambda function will have small proxy inside and will wake up small Express, actually create the small Express server inside, which is like HTTP server inside your Lambda function. So it's not really optimal solution. It will work. It's easy to do, but it kind of adds some small latency to your functions, and it's harder to debug everything and things like that. So you can build a better API, of course. And to do that, I'll be quick. You can, again, deploy your code to AWS Lambda, and you can put API Gateway in front and connect that. This looks similar. You can connect that to some different databases and things like that. And you can do that with tools called Claudia.js and Claudia API Builder. It seems similar, but it's better. It's better, why? Because you don't have a full Express.js application that we need to start every time you run, you receive the request. Your code will just answer that request. And faster in serverless means cheaper, because everything is, you pay per request, and each request is 100 milliseconds of execution of your function. So if your function answers in like 300 milliseconds, you'll pay 3 times more. So you have financial incentive to make your applications faster, because you'll pay less. So that's why it's better to build a different kind of API. And also, with that approach, you can do server-side rendering and many other crazy things. There are also Lambda at the edge functions and Cloudflare workers, which are like functions that are running in CDN that can do some changes to your applications. And of course, APIs are not that popular anymore. We have things like GraphQL and things like that. So we can do that with serverless, of course. There's a thing called AWS AppSync, which will allow you to have serverless GraphQL. But that's not all. It will have pre-configured access to AWS data sources such as AWS Lambda, Database, DynamoDB, or Elasticsearch. But even more cool is that they have built-in WebSockets, so you can have real-time updates for everything that happens inside your application. So if I put something in the database, you'll all receive the update immediately from WebSockets. And they have also the library that allows you out-of-the-box offline data synchronization, so you can have copy of your application offline, and it's cool for progressive web apps. And of course, you can add authorizers, you can add many more things, and you can minimize your backend development. And I'll quote the guy called Joe Emison, which works as a CTO and co-founder of a few companies, and he said that he don't hire backend developers anymore. He focuses on front-end developers, and he's using AppSync to do everything in the background. And he said even crazier thing, it's like with AppSync and services like that, he can hire up to 100 front-end developers before he needs another back-end developer to help him. Because those things are much faster for him now. He can build more things faster now. And the last thing I want to show you is how to do file converter. It's like things that guys from CodePen does. For example, if you want to resize the image, it works like you upload the image from the front end to AWS S3, and then that in the background triggers your Lambda function that resizes the image with image magic or something like that, and put it back in the S3 or something like that. So for example, if you want to upload one size of the image, in the background you can create thumbnails and things like that. And it's easy to program that. You can, again, deploy that with Claudia.js, and there's also a thing called AWS Serverless Application Repository, which is kind of a marketplace for those kind of applications. So if you're a front-end developer and you need to resize your images, you can go to that and search for image resizer, and you can just click and install whatever you need, and it will just work for you. So that gives you a superpowers. And I don't think we have time for demo. So sorry for that. Yeah, let me finish then everything, and then we can do it. Do you want to see the demo? Yes. Okay, let's do the demo. So I'll show you how to build a small API. Oops. Yes, I'm trying to mirror it. Arrangement. Yes. Not this. Gather windows. Live demo, sorry. Arrangement, gather windows. Oh, mirroring options. Perfect. Okay. Yes, perfect. So let me show you how to build a small API. So I'll create a folder. Oops. And enter that folder, and then I just want to initialize empty Node.js application. I'll say yes to everything. Now I want to install a thing called Claudia API Builder and save it in the dependencies. It's really small, so it installs fast. And then we want to create API.js file. In that API.js file, first thing, oops. You don't need to do this, but I love to do that. First thing you want is to require that Claudia API Builder. Thank you. Then we want to create an instance of that because it's a class. And finally, we want to add a route. And the route can be, for example, just get. And we want to answer with text. For example, hello. Something like that. And finally, I just need to export this. And to save this file, now I can do Claudia create. I need to pick the region. Because Germany is close, I can pick EU Central 1, which is in Frankfurt. and then I need to tell my Claudia where is my API, which is in api.js file, but I don't need JS because that's something that Claudia already knows. And I want to give a separate name for this, which will be Frontend Conference 2018. And then I hit enter. Claudia will install everything for me, check if I have any issues in my code, try to run the initial function, create the roles, upload everything to AWS Lambda function, create the API routes for me, and give me some URL. I'll take that URL, if I manage to copy it. Woohoo. And then I can just open new tab, go to that URL, and that's it. So it's really, really simple. Thank you. I want to show you one more thing really, really quickly. And I have a Create React app here, which I did build for. I have Scotty.js installed, so I can say Scotty SPA and source, which will be build folder. And oops, I guess I broke Scotty. I have a development version here, so let's keep that for now. Sorry. So yeah, that was it for the short demo. We can do many routes in that small function, and here's the list of the cool things that I mentioned. I promise that production version of Scotty works. If not, it's open source, so you can fix it. And really quick summary. So, summary of this is serverless is easy to start with, so go and play with it. Try to use it. It's really cool. So you don't need to maintain servers, know anything about the servers and things like that. You pay only per usage, so if no one is using your application, it's free for you. You can deploy single-page applications, you can deploy APIs, GraphQL, and many other things, and it can give you superpowers. That was it for me. The only other thing I have is, come on, my book. If anyone wants to learn serverless, there's a promotion code. The book goes from the very beginning and teach you how to build an API connected to the database, add authorizers, do many crazy things, create Alexa, skill, chatbot, and many other things. That's it. Thank you. Well done.